Welcome to my channel, and here we are going to be working on determination of the true length and true inclination of a line in space. We'll be working on determination of the true length and true inclination of a line in space. Here we are going to be making use of two methods to solve this particular problem, and we are going to have two videos for this particular question using different methods. But the first method that we are going to use is known as rotation method. So this question that we are going to use is very special, as I'm going to read the question. Then we go on and look at how we can determine the true length and true inclinations of the line. Now, the question says a straight line PQ has its end P 20 millimeters above the HP, that is horizontal plane, and 30 millimeters in front of the VP, that is the vertical plane, and end Q is 80 millimeters above the HP and 20 millimeters in front of the VP. If the end projectors are 60 millimeters apart, draw the projections of the line, determine its true length and true inclinations with the reference plane. I'll read the question again. A straight line PQ has its end P 20 millimeters above the HP and 30 millimeters in front of the VP, and the end Q is 80 millimeters above the HP and 70 millimeters in front of the VP. If the end projectors are 60 millimeters apart, draw the projections of the line, determine its true length and its true inclinations with the reference planes. That is the question. Now, so we are going to start this way. Please pay attention to my analysis of this question. Then you also will be able to solve a question like this when it comes to determination of true length and true inclinations of a line in space. Now let's start. The first thing that we are going to do here is to draw the XY line. So draw a horizontal line of any length like this. So here we are going to label this point of the line as the end X, and this is end Y of the line. Then the next thing that we are going to do is to indicate the reference planes. As we have two planes here, we have the vertical plane and we have the horizontal plane. This drawing that we are doing, we are making, is in form of orthographic views. Okay, so please follow my explanation here. So in this case now, we have this part to be the vertical plane. This is the vertical plane, and down here we have the horizontal plane. So I'm indicating the reference planes here. So this is the vertical plane, this is the horizontal plane here. Okay, so I believe we can, okay, we can see this. Okay, this is the vertical plane here. So here is the vertical plane. Let me write it down here. Okay, and this is the horizontal plane, so HP. Okay, so we have this to be horizontal plane. Now the next thing that we are going to do is that we take the set square and then we move away from this end X of the XY line. So we draw a vertical line. Okay, so what is the purpose of this? As we are told that the end projectors of the line are 60 millimeters apart. So starting from here, so this point, I'll call it point O, that is small letter O here. Okay, then from this point O here, I will take a measurement of 60 millimeters on this XY line, as the end projectors are 60 millimeters apart. So this is 60 millimeters. So this point here, I will call it point O prime. Okay, so here we have this should be O prime. Then I'm going to draw a vertical line here again. So I'll draw a vertical line. So through this point O here. So I will have it like this. Okay. All right. So the next thing that we are going to do is to go into the question now. Though we have made use of part of the question that is for the end projectors, which is 60 millimeters apart. All right. So the next thing that we are going to do is that, as we are told that end P of the line is 20 millimeters above the HP. So that distance that is above the HP, so you will take it here on the vertical plane. That is from this point here. So we take 20 millimeters up. So this is 20 millimeters up. So then I'm going to call this point. So this point is point P, which is 20 millimeters above the HP. Then we take it in the VP. Then we are also told that that same end P is 30 millimeters in front of the vertical plane. So that distance that is in front of the vertical plane, so we take it down this XY line in the horizontal plane. So from this point go here, we take 30 millimeters down. And this point is point P, okay? This will be P prime here, all right? So let's take note of that. Now, the next thing that we are going to do is to determine where we are going to put point Q, as the question continues and say, and Q is 80 millimeters above the horizontal plane. So that 80 millimeters that is above the horizontal plane will come to this point here, okay? Then we take 80 millimeters up this XY line from this point O here, take 80 millimeters up. So this is 80 millimeters. So this point is point Q. This is point Q here. Okay, so we call it Q prime. All right, then we are also told that this same end Q is 70 millimeters in front of the vertical plane. So that 70 millimeters, you take it down from this XY line at point O here, take 70 millimeters down in the horizontal plane. So this point here, we call it point Q. So this is point Q here. All right, so the next thing that we are going to do now is that we are going to join this point, 2 points together. So we join point P prime and Q prime together to get the line in the vertical plane. Okay. So this line is the front view of the line. So this is the front view of the line. Then to get the plan of the line, so we join these 2 points together, points P and Q, we join them together like this. So this is the plan or the top view of the line in the HP. All right, so I believe you are following my explanation. Now, the next thing that we are going to do is that we are going to draw a horizontal line from this point P. So we draw it to this side, okay? And this point where this horizontal line touches this vertical line, so we call it point Q1 prime, okay? Then we come up here also, so we draw a horizontal line like this. So where this line touches this vertical line, we call it point Q2 prime. All right, so let's take note of this. Now, the next thing that we are going to do, we are going to draw a locus line. So that locus line, so through this point here, through this point Q, so we draw a locus line within long chain line, so we have this. And then we come up here also through this point Q prime, so we draw a locus line. So a locus line is drawn with thin long chain line. All right, so we have this now. So let's call this line. So we call this line, we call it, so point A, B, okay? And then here we call this, so A prime, so B prime. So we have what? We have this now. All right, so let's go on. Now, the next thing that we are going to do is that we are going to be working on how we can determine the true length of this line and true inclinations. But before that, as part of the question, we are asked to draw the projections of the line. So for what we have done here already, we have drawn the projections of the line. We have drawn the projections of the line. So the next thing that we are going to do is to determine the true length of the line and also the true inclination. Now, as I said that there are two methods that we can use in determining the true length and true inclinations of a line, and we are going to make use of the first method now. And this method is known as rotation method. We call it rotation method. Now, let's go. So we take the compass as we have here. So we take the compass as we have it here. So we are going to put the pinpoint of the compass here at point P, and we extend the pen point. We extend the pen point to this point Q prime on the line. So we put the pinpoint at this P prime here on the vertical plane, and we extend the pen point to point Q prime here on the vertical plane. So then we make an arc. So we rotate like this. So this arc touches this line P prime Q prime 2 at this point here. So from this point here, we are going to draw a vertical line. From this point, we are going to draw a vertical line from this point. So we come to this point, okay? So we draw a vertical line down. So we draw a vertical line down here to touch this horizontal line, okay? So now, so this point where it touches, okay, it comes down. So we bring it down. So bring it down to this point. We are still bringing it down to this point here to touch this locus line. So this point where it touches the locus line, so we are going to call this point, so we call it point Q1. So that this is point Q1, and then so we are going to join this point P and Q1. So we join them together, point P and Q1. We join them together like this, okay? So join them together like this, okay? So here in the horizontal plane, so we have this line to be the true length in the horizontal plane. So we have this to be true length in the horizontal plane. So we have this now. So let's look for the true length here in the vertical plane. And what we are going to do again is that we put the pinpoint of the compass here at point P, and we extend the pen point to point Q here, and then we rotate again. So it goes like this. So touching this line at this point, this horizontal line at this point, and then from this point, we are going to draw a vertical line. So we draw a vertical line from where the arc touches the horizontal line. So we draw a vertical line. So it goes up here. So it goes up here, and then so it goes up to this point, touching the locus line. So it goes up like this, touching the locus line. So I need to close this. Okay. So now, so this point, so where it touches this, so I will call it point Q2. So this is point Q2. So now, so we are going to draw a line by joining this point P prime and Q2. So we join them together with a straight line. So we have this to be the true length on the vertical plane. So this is the true length on the vertical plane. So we add this to be true length on the vertical plane here. So this is the true length on the vertical plane. All right, so now, so we are determining the true length. And what is the true length? So let's write down what the true length measures. So for this, we have this. So we are going to get the same thing. It should be of the same length. So we have what? We have the true length. So true length, so is equal to, so we have this true length is equal to what? Is equal to PQ1. So PQ1. So here we measure. So let's also write here. So true length here also, though we must have the same thing. So it's equal to what? Is equal to P prime Q2. So P prime Q2, so is equal to, so let's take the measurement of the length of the line. So let's take the measurement of the length of the line here in the vertical plane. So we have this distance to be equal to something like, we have 94 mm. So 94 mm as we have it here. So this is 94 millimeters. So we have 94. Okay, so 94. So plus or minus 1. So just add that. So if we also take the measurement of the true length here in the horizontal plane, so as we can see here, we also have the same distance. So 94 plus or minus 1. So here we have this to be equal to 94. So plus or minus 1 for the true length. Okay. Now, so we have determined the true length. Okay, now let's go and determine the true inclinations. True inclinations. So here we are going to, so let's make this angle. Let's make an arc here. So this is the angle that this true length forms with this horizontal line, and also the angle that this true length makes with this horizontal line. Okay. So I'm going to say something special here. So let's listen. So what is the value of these angles? What is the value of these angles? So let's start. So what's the value of these angles? So I'm going to place my protractor like this on this line. Okay. So looking at what we have here. So looking at what we have here. So I have this angle to be, so this angle as I'm looking at it here. So this angle is around 40. So it's around 40. So I'll just take it as 40 degree. So as I can see it here, 39, 40. So I will say this angle. So let's call this angle. Let's say this angle is angle theta. Okay. So we have angle theta to be equal to 40 degree. So 40 degree. And this particular angle here is the angle that the line makes with the vertical plane. So this, with the horizontal plane. So it's the true inclination to the HP. So true inclination to HP. So let's take note of that. So true inclination to the horizontal plane is 40 degree. True inclination to the horizontal plane is 40 degree. So then if we call this angle, so we call it angle alpha. Okay. So what is the value of this angle? What is the value of this angle here? So if I turn it like this and then I take the measurement of the angle. So this angle is what? Is 25 degree. So here we have angle alpha. Okay. So to be equal to what? To be equal to 25 degree. Okay. And this particular angle is true inclination to the vertical plane, to the VP. True inclination to the vertical plane. Okay, so we have this. All right, so this is what we are asked to do. We are asked to draw the projections of the line, which we have done, and we are asked to determine the true length of the line, which we have done. Then we are asked to determine true inclinations of the line, which we have done. So we have determined the true inclinations of the line to the vertical plane and also to the horizontal plane. It's as simple as I've done it here. All you have to do is to practice. We are still going to do more of this, but next thing that we are going to do is to use the second method. As I said, that this first method that we use is known as rotation method. Thank you and God bless you.